My name is Neil Romine. It's not easy. I like the challenge. I like the motion controls, the high precision part of it. The fact that my customers are getting involved in some pretty cool stuff, and I get to be a part of that.
I think part of the problem is right now, whatever their power source is, it's very limited on time-wise, and this would almost make it more of an unlimited thing and keep it in the airspace.
It's a 2-foot diameter telescope, which means it actually rivals the original telescopes that were being deployed in the 1900s for examining things in outer space. Simultaneously, it's got a path for a laser to go through. So you're actually doing target tracking, you're doing, image magnification, image tracking for an object that's miles away.
It's designed to basically recharge the drone in flight. So the device doesn't have to be landed and recharged, the battery's recharged and then sent back up again.
And this would almost make it more of an unlimited thing and keep it in the airspace. And that's the most of it. And then it's got some really unique and really, I think, parts on it that have probably never been done before. It's very custom, so.
My customer, really didn't have a written spec. They wanted to just kind of throw something out there and say, hey, this is kind of what we want. What do you think? And I work well with that. I mean, I deal with that, I think, as best as anybody can. You collaborate with them and talk over it and negotiate, as things go by, time goes on.
It is a gimbal-mounted, highly precise telescope. What I've basically been telling my friends is, oh yeah, I'm working on the death laser.
So I've known Neil for a long time. Me and his daughter actually went to college together. And so I knew what he did, and then when I went looking for a job, I said, hey, could we do something together? And we did.
This would allow aircraft to stay up in the air, so unmanned aerial drones, as long as it can keep the battery charged, it can stay up there.
I've always understood from the very beginning that it was basically something to do with drones and the solar panels on them, and this would be some mobile unit that they could use to charge the drones in flight so they wouldn't have to land them.
I really like the technology, getting involved in technology. The fact that this type of work requires electrical, mechanical, software engineering, from a design perspective. And that's very rewarding to get involved in a multidiscipline like that.
I've known Neil for 40 years, I think, maybe a little less than that. And when he got this telescope project, his main focus was the telescope. The customer then also asked whether Neil could supply transport for the telescope. Putting the trailer together was, metalwork, sheet metal, welding, carpentry, things like that. And none of that stuff was unobtainium. It was all just a matter, like I say, of scheduling the manpower to get the tasks done.
Neil really is truly brilliant. It's kind of inspiring to work with him sometimes because he has such a grasp on such a wide amount of technical knowledge. He's able to break it down and digest it in a way that is very trainable and very teachable.
Your primary function is this gimbal. It's designed to be able to follow and track a moving object at a distance pretty quickly. What the cool thing is that the path that the visual is going to take is through a series of mirrors into the command center.
I tried to support them by keeping, doing more of the internal stuff so that they were able to go out and focus more on the Blue Joule project.
I facilitate the communication between the milestones that the engineers have reached and translating that over to the client, handling really the full administrative side of it.
So one day it could be building circuit boards, the next day it could be anodizing, day after that, hey, we need you to 3D print this item here. Basically the back support bearing for the servos that adjusted the mirrors. So then a few little running changes were made on it so that everything would stay together and operational, and so far they hold up just fine.
So how do you get a beam, whichever direction you want to go, how do you get the light to go from a mirror that's moving to a stationary, or stationary through the mirror? And that requires a bunch of mirrors that form a path through the system, and you can't have the beam coming in at some offset from the center of rotation. Otherwise, you're not it's not tracking through the system accurately or at all. It's called a coup de path, and that is a whole series of mirrors that bounce the beam off the table, under the floor, up through the one axis, through the arms, and then into the telescope, and then back and forth, normally through the telescope.
So when the project started, I was primarily on designing the gimbal, the telescope itself, and that part, and someone else was designing the trailer.
Once the design of the structure of the trailer was relatively complete, we could help Neil with fine-tuning it, tailoring it out, and then doing the full job of cutting, fabricating, welding, whatever we needed to do to bring this thing to fruition.
I then had to take over that part of simultaneously refining it and documenting any changes that we had to make on the fly, because some things you don't find out until after fabrication starts happening. We got through it, designs got changed, and everyone had different ideas, but ultimately it just kind of ended up falling into place bit by bit.
The trailer thing and stuff like that was all with Blue Joule and everything. That was a major undertaking. Difficult from the get-go. It's a mobile system, obviously designed to be taken to wherever it needs to be, remote locations or whatever. It's powered by an external generator system.
It was more of the 3D printing, I think. As I said, getting that back support bearing to hold together so that everything stayed nice and precise. That was some frustration at first, because you go through a couple iterations, and every iteration you're like, well, this has got to get it to work right, and then it fails, and it's okay, back to the drawing board, try again. You just keep persisting until you finally get something that actually works. I didn't think it was going to get as complicated as it did. I'm glad we finally got it, but at the same time, it's always easy in theory. Practice is a different story.
I've been putting together the guide to how to work the trailer as a whole. There's innumerable user's manuals for all of the various components and pieces and motors that comprise this trailer.
The key things to consider when designing a system like this is weight. What is the base system, the base chassis that you're going to be putting all of this onto, and what's going to move it? Is it going to move? Majority of the systems that we design are usually going to go on something or be hauled by something. So our key thing is weight. That's always going to be something to look for.
If it makes it there and back, safely, that'll be an add-on, not a part of the design.
Yeah, yep.
It's looking good right now.
Yep, we're around the corner and it's still upright, so I'd say it's success.
So your trailer, what's its weight limit? How heavy of a vehicle do you need to haul it? And most importantly, you also have to consider where is your center of mass. Because you don't want to have too much weight in the back and then all of a sudden you have a truck go flying. You don't want it at the front, otherwise you're going to be dragging your truck.
Doing this for their DMV, right?
And not just in the whole system itself, it's also in the individual components. So like even in our gimbal telescope, we need to know where's the center of mass so that if this thing's motors are not on, is it going to tip one way or the other? How much strain is there going to be on the motors? So there's a lot of balancing going into it.
There's a bunch of difficult challenges on this. Just dealing with the unknown of the weight and the weight distribution has been a big challenge. And, we're not totally out of the woods yet. We've, just weighed it today and had a little bit of a surprise on how much tongue weight there was. That's a problem to solve going forward.
The system is very, very heavy. It was a pretty big concern as far as whether we're going to be overweight and all kinds of concerns with that regard, just based on all the estimates that had been made regarding the amount of steel and wood and everything else that went on there. So, but fortunately, we were able to, come under the 28,000 pound limit.
Halfway through building, where we had to switch out axles, reinforce frames, and make sure that not only was this thing functional, but that it was safe. It's hard to keep things moving. We work here out of Florida, and one of the things that we had to deal with was 2 back-to-back hurricanes while our trailer was out there. Making sure that our equipment was safe, handling setbacks while we dealt with repairs to just be able to access our yard again.
A lot of times, guys, it's me sitting on Google and doing some research for a while and trying to figure out what direction I'm going to go. I think I would have lost my cool at some point, or lost my mind at some point with this whole project. And no matter what seemed to be going on, like we were just talking about before, you got to drop back and redo stuff sometimes.
You just keep persisting until you finally get something that actually works.
My original concept was just this almost Rube Goldberg kind of mechanism in there with all kinds of, adjustments, and really backed off of that. It just became too complicated, and we came up with a design, I think, that's much, much simpler and stiffer. That's the big thing. All the commercially available mirror mounts are designed for stationary application, and we're very dynamic, moving around. So you've got all this weight that you're trying to control in a very stiff manner, so it's not wobbling around. The image is not wobbling around, and that was quite a challenge.
2 years later, it's done. The whole thing works. I'm stoked. It's really been a cool path to walk down. So, yeah, I've been having fun the whole time.
Remembering the first couple times we were there when we had the generator up and powered the thing up for the first time, start to actually see the gimbal function, start to actually see the trailer in action doing what it's ready to do, seeing it move for the first time. It almost feels like, hey, that's our baby and she's walking.
Being with the project from the beginning, and it's starting off with 2 people to suddenly a team of like 10 plus, it's been very interesting because we got new people coming in, new people with new ideas. But the bottom line is that we all get along and work together. And also being able to learn from other people with their ideas. Since it went from a team of 2 to 10, all of a sudden you got new ideas coming in. It's like, oh, hey, that is a good idea. Wouldn't have thought of that because of all of our different backgrounds. I have more experience in visual design and carpentry. Neil has more experience with engineering, programming, and just overall mechanics. John and Rich actually with their electrical knowledge and all of their, 60 plus years experience. Like, it's really neat to learn from each other.
You're doing, image magnification, image tracking for an object that's miles away to point a laser at it and, illuminate that object with a laser. And all of it has to be mobile, basically a 270-degree field of view. So you park this trailer, you've got a huge image range that you can view with it. And it's like every other telescope, it magnifies stuff from a distance. This one has the additional optic path for the laser going out the other way.
They're going to be able to run a whole bunch of different experiments using this and transport it out to different ranges, different locations. My hopes are that they will have an easy time running their experiments, which are going to be on the optical table. And the gimbal and that kind of stuff is just an extension that they don't have to worry about. That's my hopes there. And it never works out completely that way. They're going to discover, limitations or whatever, and we'll either address them or, compensate for them somehow.
One of the key aspects of helping to manage this project is it's always making sure that we're keeping with our clients' deadlines and keeping with our clients' expectations.
In here? Okay, great.
I think the specific target that we were told was the use of the device is in-air refueling of electric drones. And I think that is a phenomenal use of the technology that we have available to us. One of the major problems that we have in military frontline operations is they can put drones up to keep the airspace around our military installations safe, but those drones have to land for refueling. What this allows us to do is to refuel those drones in the air so that they can fly 24/7. So I think if it's deployed in a military setting, I think this gives us the ideal opportunity to keep our troops safe and, into the future. I just think that's a really spectacular goal for this product.
My overall hope for the project is that we have learned everything needed to learn so that even when we do this again, it goes a lot smoother because this was a whole prototyping project. You're going to find almost all of the problems in first go with prototyping. That's the whole point of prototyping. So what I'm hoping is that when this is done again, we have learned all the lessons we need to learn, knowing what we know now and making all the mistakes we've made, that it can just get bigger from there.
You know, forefront in my mind is lessons learned kind of things on doing this kind of development and work, and the specific things that I you know, you always get into a project like this, and towards the end you go, oh man, it had been so much better if I did it that way, or you know, use this technique or whatever, and there's always a few of those, but long term I want to, well, first and foremost I want to remember the people, you know, the collaboration, and you know, the lots of good effort that has gone into this, and that's valuable. You know, that's a good memory.
I hope to ignore all of the scheduling issues, the manpower issues, and just remember the successes, and just, you know, getting the sheet metal on the outside of the unit, and it all fits and everything lines up, and having Shane involved, you know, that metal that's screwed onto the outside of that trailer, if you look at it, it's actually assembled differently than every other installation of that material. All the screws in every other installation are at the top of those peaks. Shane's custom printed those V washers to go in under the screw heads so that we could put it in the valley and keep the rain out of it. Just, you know, challenges like that, just all of those kind of things where, boy, that's weird, we're going to have to do something different, and then we do something different and it works a whole lot better. So I'll remember those things because it's been a blast.
I am really excited to see this thing in action in its full glory. I feel so proud to have worked on something so incredibly advanced, and I feel really lucky to work with the company that I work with. We have a great team here, and what we do it's fascinating work.
Use your outside voice and give me that answer.
The outside voice?
Yep.
This project has been heck. I want it gone. It has been here longer than it was supposed to be. You are cutting that last one.